Our new group, use the materials at your table to model the atom of your element. Okay? Does that make sense to you? Hi. How you doing?
Good, are you?
Good. So you're going to match that to the table. You know how this works. Hello. Hello. Good to see
Am I supposed
you.
to be in here? She's like, I don't know. I don't think so.
All right. What are you doing? What, you switched in here?
Uh-huh.
Your fifth period now?
Yeah.
All right, take one of these. Good to see you. Come on in. So you're going to find your table, okay? Actually, I want you to sit right here, okay? What about Brooke?
Because she's here, but...
Well, when she comes, we will catch her up. Okay? All right, so you're going to use the materials at your table to model the atom of your element.
Neutron?
There you go. Eight, okay. You have a science textbook there, just in case. Just in case. Whatever you want. I would do it on here. It's probably cleaner.
Oh God! Oh geez! Oh no!
How do you get good Skittles? We got green and...
What do you mean, good Skittles?
Green is so nice.
Skittles or Skittles?
Red's the best.
Are you ever?
Green are good. Like,
Can you just be happy?
leave the table if you don't like green.
How are you?
How come you didn't know me? I was gone in second period.
Electrons, yeah, because
I wasn't here second period.
so,
I'm only here today, like this period. That's it.
There's 9
Yeah, I switched to this period.
Oh, well that's good. You like it better?
Let's get them into groups of 9.
Sort of.
This happened when I changed my schedule out of 6th grade to 7th grade.
All right. So we're gonna focus on the atom. How are you doing with this? Are we doing good with the atom?
Electron, proton, neutron.
Perfect. This is what we're doing right now. So we're gonna model this specific one.
Okay.
Isaac can help you, right, Isaac?
Yes, we're doing so good.
What is that?
We have 3
Is that a peace sign?
You're embarrassing. Yes. All right, it's 3
All right.
protons.
Let's talk it out.
So it has the same number of protons as electrons. I learned something here.
Perfect.
So 3 protons. That's like the nucleus, okay?
Okay.
And we put
But
the same number of electrons.
okay. Where are protons and neutrons in an atom?
Well, the protons and neutrons are like around the nucleus, right?
They are. The protons and the neutrons are not around it.
Are they on it?
They're in the middle
That they make up the nucleus.
So
So there's that little gray dot right there, right in the middle.
Maybe you should put them in the...
So the okay. So you've got protons, neutrons. What's the other subatomic particle? And why would I give you nerds?
To make nucleus?
Uh-huh.
electron cloud.
Oh. What? That's a beautiful, like, relaxing looking thing. But what's going on here? It's almost Halloween. We're getting there. So what's going on here? Talk me through it.
These are the electrons. No. Okay, so these are the protons, these are the neutrons. There's 6 protons and 6 neutrons. And then there's also 6 electrons.
Okay. Okay. So tell me where in an atom the protons and the neutrons like live. Where are they?
In that center.
So does your model look like that?
I was wondering, is this the center or...
Oh, I see you. The little gray dot is the center. Good question. So the thing that came up was the big outside circle. That's like the outer boundary of the entire atom. The little gray circle in the middle is the center. The nucleus. Good girl. Of course. Let me make sure that yours is right first. All right, so tell me about your model.
Okay, it's the fluorine,
Mm-hmm.
and it says the atomic mass is 9, so there's 9 protons. Atomic number.
That's okay.
There's 9 protons,
You're just happy. You're excited. I'm here.
9 electrons, and 10 neutrons.
So you've got 9 protons,
Yes.
9 electrons,
Yes.
and 10 neutrons.
Yes.
The protons and the neutrons are in the nucleus. Yay. The electrons are
Not in the nucleus.
Around
Do they
it.
have
Perfect.
to be in it?
And you chose the size because.
Oh, like the number?
They're super tiny.
Okay. Okay. So now step 3 is going to be you're going to label with that dry erase marker all of these parts. So all of these things, electron cloud, nucleus, proton, neutron, electron, positive charge, negative, like all of the things.
Wait, all those things
Oh, wait,
right
with
down
The
there?
electron do a
still on there?
positive and neutron.
Go.
A neutron.
You guys are fabulous. Look at you. Nucleus, proton, neutron, you got the charges, you've got the electron cloud. Are you missing anything? Where's the mass? So you've got 1 AMU and 0 AMU. You guys might be the winners. Oh, what's an AMU? What is an AMU?
Atomic.
Ooh, yep.
Atomic mass.
Atomic mass unit.
Oh.
Yeah.
Cool beans. Cool beans.
Good job, good job, good job. Perfect.
That's 4.
Got it?
Done.
Ryan's super excited.
Oh, this is a race.
Love it. Great job.
Can I eat the nerds?
You may now eat. Once I check you off, you can go ahead and snack. Yes?
Atomic mass.
Atomic mass unit. So that tells you the mass of the individual subatomic particles. So there's a reason why you put these bigger Skittles here in the middle and the nerds on the outside. You know this deep down.
We're supposed to add them all up together.
You're just going to tell me the atomic mass unit of each subatomic particle.
Okay.
Does that make sense? So the proton's AMU is what? The neutron's AMU is what? The electron's AMU is what? Got it?
Okay, we're done.
Got it? That looks so much better.
Can we have extra Skittles? Because like I think we're all kind of hungry.
All right, we're getting there. You're close. So now you need to label.
Label. Wow.
Look right here.
Oh,
Look right here.
you played us.
You didn't read all the directions. What is that? What's this? What's this? Is this an asteroid belt?
Yeah.
I told him to make it more like a cloud. They
All right.
on the circle.
So you have how many protons?
Oh, we have 3.
So how many electrons should you have?
3, C, easy. Oh, 1, 2, 3.
No, okay. So those are your neutrons, right?
All right, yes.
Okay. So they should stay in the.
All right, but then what are the electrons?
The electrons are going to be those meteor-looking nerds that you've got going
So
on.
we're supposed to only take 3. Yes. We're supposed to get rid of all of them except for 3.
I would use the baggie.
This is such a waste.
No, it's not. You get to chomp on them.
All right, so after you.
All right. You got it?
What are the AMUs?
AMU?
Those. Wait, do we have to put everything like from down there?
Tell me what an AMU is.
Okay.
Got it? All right. Nucleus, neutrons, protons, electrons. Where's the charges? Tell me.
Oh, the charges. The proton, the negative charge, the positive charge.
Which one's which? Proton has what type of charge?
Protons have positive and electrons have negative.
And electrons have. Awesome.
So
Perfect.
about the
You can eat.
Skittles.
You can eat.
About the Skittles.
Oh, perfect.
You can eat. You can eat.
Wait, I'm confused on what the 1 and the 0
I mean, it's just 0. So if you don't confuse it as like an O. That's all.
Wait, so like would the 1 A and B be just as
Look at them like stealing all the Skittles.
So the proton has 1 AMU. The neutron has 1 AMU. That's the mass of them. An electron would have 0 because it's so small that we can't measure its mass. Yeah.
I want more purple than that.
I only got 4.
Here we go. You guys are good. We talked it out.
Oh.
You got it.
So we don't have to write marks on.
Nope, you're good. All right. Hi.
Hey.
Great job, guys. I'm passing out to you what we're going to do next. I am super impressed. Good job on this. Feel free to snack on the Skittles and nerds as we go through the next part. Okay? So you're going to need a pencil. Just moving forward. All right. So somebody share with me, what object did you use for the proton? Isaac.
We use the Skittles.
You use the Skittles. What about the neutron?
We also use the Skittles.
Okay. And what about the electron?
We use the Skittles.
You used the nerds. Raise your hand if your group did the same thing. Awesome. Okay, why did you use those particular pieces of candy for the protons and the neutrons and then the nerds for the electrons? Tell me, Savannah.
I think I did it because the Skittles were larger than the nerds, and also yellow is usually more of a neutral color. Green is more of a positive color, and
Okay.
red is more a pink. Red is more of a negative color.
Okay. Interesting take. But I like how you said that you use the Skittles because of the size. So what do we know about protons and neutrons in terms of size of subatomic particles? They are what than electrons? Big. They're bigger. So you're going to use the bigger piece of candy, which is what you did. That's great. For the protons and the neutrons, the electrons, which are the smaller nerds on the outside. How did you know how many electrons to put?
There are an equal amount of electrons to protons.
Perfect. How many of you guys got that? So you knew how many electrons to put because you know that the number of protons and electrons in a neutral atom are always equal. Yes? Perfect. Awesome, awesome, awesome. All right. So this is just a recap of what we just talked about. So atoms in their natural state always have the same number of electrons as they do protons, which you guys are well aware of, so well done.